In this video, we will demonstrate how a column deforms when it is subject to an eccentric compression. The column is fixed at the base. First, we will look at how a column bends along two different directions. When a horizontal force acts at the top end, from right to left, the beam will bend to the left. As introduced in previous beam bending video, the length along the middle neutral axis will not change. Therefore, it is not subject to any compression or tension. This neutral axis is defined as the major axis, and we say the column is bending about the major axis. The left surface will become shorter. It has the largest compression. The right surface will become longer. It has the largest tension. We can look at the deformation of the column again. Now, let's look at how it deforms when the force comes from another direction. The column will bend backward. This time, the wide middle plane becomes the neutral axis. We define it as the minor axis, and we say the column is bending about the minor axis. Then, the back surface becomes shorter and has the largest compression. The front surface becomes longer, and it has the largest tension. We can look at the deformation from the another angle. Now, instead of a horizontal force, consider a vertical downward force acting at the centroid of top surface. It will compress the whole column. The column will become shorter, and the top end surface remains horizontal. We say the column is under axial compression. However, if the vertical force acts eccentric to the centroid, that means it acts at a certain distance away from the centroid, the column will shorten and bend at the same time. The column is now under eccentric compression. The top end surface is no longer horizontal. It actually drops and rotates. The angle between the top end surface and the side surfaces remains at 90 degrees. The left side surface has the largest net compression due to axial compression and major axis bending. The right side surface has a smaller net compression due to axial compression and the tension from major axis bending. Similarly, when the vertical force acts eccentric near the front edge of the top surface, we can see that the column will be compressed and bent along the minor axis. Again, the top end surface is keeping a 90-degree angle with the side surfaces. We can see the deformation again. In this case, the front surface has the largest net compression, while the back surface has a smaller net compression due to axial compression and tension from minor axis bending.